In this question, it says an object is placed at a distance of 30 centimeter from a convex mirror of focal length 15 centimeter. So we have to find the image distance. But the distance of the image is always by default has to be from the pole only. All distances are measured from the pole of the mirror. So irrespective whether it's pole or not means the same thing. Now let's first use symbols to find out what we are given here. Symbolically, we can say that the object distance is 30 centimeter. By convention, object is always placed on the left hand side of the mirror. So u is going to be minus 30. Now further, we are given the focal length. As we know that for a convex mirror, the focal length is virtual, that is on the right hand side. That's why we are going to take the focal length. This is principal focus and this is the focal length. This should become as positive 15 centimeter. And what we have to obtain is the image distance. What we know, image distance is denoted by the letter V. So V is our question. For that, we are going to use that mirror formula. So let's say if I use mirror formula here. So the mirror formula is 1 over V plus 1 over U is equal to 1 over F. So V is missing, so I'll keep it V. And this is minus 30. So plus minus is minus. We don't write minus in the denominator. Is equal to 1 over 15 centimeter. Now on transposing 1 over 30 to the other side, it's 1 over 15 plus 1 over 30. Taking the LCM, which is in this case is 30. This will be by 2 times and 30 1 times. So we can figure out from here further that 1 over V is equal to 3 over 30. That implies 1 over 10. And by cross multiplication, V comes out to be positive 10 centimeter. Now, we have two things. First of all, we can figure out that the distance of the image from the pole is 10 centimeter, but this is positive implies that it is behind the mirror. And although the sign here indicates this is positive 4. So we say that we know that in convex mirror always forms virtual erect. That's why we will go for this option. In this MCQ question, it says an object which is 100 mm in front of a concave mirror produces an upright image that is virtual and erect. We have to obtain the radius of curvature, or to tell the radius of curvature will lie between which of these. Now let's say for that, if I make a concave mirror, this being a concave mirror, and I made its radius of curvature, sorry, not radius, principal axis as this. Let's say this be the pole of the mirror, this be its focal length, and say this be its center of curvature. Now the question says that image formed is virtual erect. As upright stands for erect, and we know that image formed is upright when the object image formed is upright, when it is virtual erect, and in that case the object must be placed between F and P. Anywhere between F and P could be this also. Now, as for the question, we can see from here that the object is placed 100 mm. So I can say that this is 100 mm. So from here, we can figure out that the focal length has to be greater than 100 mm. And we know that radius of curvature is twice the focal length. We can say that radius of curvature will be twice of F. That means since F is greater than, let me figure out once again. This is F and this is R. So we can say that if F is more than 100, R, which is twice the focal length, has to be more than 200. So therefore, we'll say that the radius of curvature, with ignoring the sign here, will be more than 200 mm.